Yeah, section 2 deals with functions and graphs. What is a function? I know you've heard it before. What is a function? I know in junior high or high school, what you've seen is here's an equation. You put something inside there, you put it in a machine, and it spits out the answer. Yeah, that's usually why everybody sees it. But what a function really defines is this: a function is a correspondence and we'll talk about this one in a second, between one set of input values called the domain and another set of output values called the range. For right now, let's look at this. Okay, the input values. You have an equation here. Can you tell me what y is with the value of y? The value of y. That's an equation. There's a difference between a value and an equation or an expression. Y doesn't have a value yet. Does x have a value? No, it doesn't have a value. It can be any value you give it. X is what's called the independent variable. X is called the independent variable because you can't tell me what y equals unless this whole side has been finished. And what's keeping us from doing this side? The value of x. So you can pick any value x you want. There's no restriction. Once you pick a value of x, give me a number for x. Once I pick a value of x, it's now defined. I plug it in the equation and work it out. 0 plus 2 is 2. Now y has a value. Y is a dependent variable because it can't get a value until x has been defined. So the value of y depends on the value of x. So this is my input. This is my output. These numbers come from the domain. And these numbers give us the range. Notice I said comes from the domain, gives us the range. Because we can only use x values that are valid. What does that mean? Remember, for we first have to define the independent variable first. Are there any restrictions to X?
Yes.
Remember, we have to ask 3 questions. Can X be negative? Can X be 0? Can X be positive? Those are the 3 questions that you have to ask when you look at the values that for your independent variable, for what you're going to put in the function. We're going to get to a point where we're going to talk about all the functions in mathematics. But for right now, we have a fraction. What's the only rule we have about fractions? What's the only rule we have about fractions? You're close. Cannot be 0. So the only rule we have is the denominator cannot be 0. It can be negative. If I put 1 over negative 2, it's the same thing as negative 1/2. That's not a problem. Can I put 1 over 0? No, it's undefined. Can I put a positive number in there? Yeah, 1/2 is 1/2. So now we've just defined the domain. Our domains from our numbers is the X values. We can go from negative infinity to positive infinity, but we cannot use 0. I put an open circle there because I can't use it. I can use everything else. I cannot use 0. So my domain is from negative infinity to 0, and then from 0 to positive infinity. Again, don't worry about the symbols here. We're going to define that at the end of this chapter. But this is what we mean when a domain. It's what are all my possible X values I can use? Are there any X's I cannot use? All right, so we have, that's the X is the input. Once I plug an X value in there, I work it out, and then it spits out a Y value. That's my output. That's the range. Those are the values that my answers become. Let's go back to the question, to the definition. A function is a correspondence between a set of input values and a set of output values. So here we have our values of X, and here are values of Y. These are my inputs, these are my outputs, my domain and range. This is my domain, this is my range. So as I said, it's a correspondence between the first set of values and the second set. So that's what I was saying, is this number here corresponds to one number only, or a number, I should say. Why do they use the word correspondence? There's a correspondence between each of these numbers and each of these numbers. What's another use of the word correspondence? When have you ever heard that word before? Or if you ever have heard the word before? What do they used to call mail in the old days? In the old days, I'm talking about before 60s and 70s. Maybe in the 80s, they call it that. When you sent a letter to somebody, okay, letters are the things we write and put a stamp on. Okay, and even more so is, let's go back even to the beginning of the Old West. How did mail get delivered in the Old West? Well, who delivered it? The Pony Express. I'm talking about way back there. So what happens is one person writes a letter. Here's person A. They write a letter. They send it, and it goes by Pony Express or the mail courier to another person. That's correspondence. We call that a one-to-one correspondence. In other words, one person to one person. Can this person send the same letter to two different people? Not unless they live in the same house, because it has to be the same letter. You cannot send the same letter to, or you can't give the same gift to two people. If you give the same ring to two women, you're in trouble. So one to one means X only gives one Y an answer. This with these two is not one to one. In writing one to one, we use that symbol instead. The one, it's not one to one. This is important because when we start talking about correspondence, it can only go from one to one. In other words, so this is a function. Can they all go to the same Y value? Would that be a function? Because a function, remember, this is a correspondence from an input, which is X, to an output, which is a Y. One and only one. That's a function. Is that a correspondence? Why? I'll tell you why. Because as long as for each of these X values, there's only one arrow going out of it, that's a correspondence. The problem comes when one X value has two arrows coming out of it. That's no longer a correspondence. That's now a relation. A relation is when you have correspondence with at least one person or one other item. So this is a relation as opposed to a correspondence. Now, let me show you some examples of what those look like. Here's an example. Is the first one a correspondence? Yeah, because you notice each one of these numbers only have one arrow coming out of it. So it's automatically a correspondence. How about the second one? Is that a correspondence? No, because Jefferson sent to Stephen Breyer and Ruth Ginsburg. Bush, George W. Bush, Samuel Alito, and John Roberts. So is this a correspondence? Is it a relation? Yes. So again, once you see one of your X values with more than one arrow coming out of it, it's no longer a correspondence. You have all this stuff in your notes. You don't have to write this stuff down. Take this. Let's look at the next one then. Determine whether the following correspondence is a function. Remember, a function is for every X, there's only one and one Y. The domain is this. Year in which a presidential election occurs. The correspondence, the person elected. The range is set of presidents. Is that 1-to-1? You say yes. Why? You're right. It is yes. One president. Very good. That's exactly right. For each year a president is elected, there's only one president elected. Except back in the Civil War, when there were two presidents, one for the North, one for the South. And hence the Civil War. All automobiles produced in 2014. Each automobile VIN number, a set of VIN numbers. Is that a 1-to-1 correspondence? So these are all the automobiles, the set of VIN numbers. Why is it 1-to-1? Very good. Because each car has their own unique. Anybody does not know what a VIN number is? VIN number stands for vehicle identification number. That's if you're sitting in your car, it's in the bottom corner of your windscreen. That's how you determine what your car really is, who made it, when it's made, where it's made. The set of all professional golfers who won the PGA tournament in 2013. The range is the set of all PGA tournaments won in 2013. Is that 1-to-1? In other words, can the same person win a golf tournament more than once? Because of that, it's not a function, not a correspondence. Because the moment one person can win more than one tournament, it's no longer like Tiger Woods. He won almost everything that when he was in the pros. So that's definitely not a 1-to-1. The set of all PGA tournaments and the set of golfers who won PGA tournaments. Yes, because why? Each tournament, there's only one winner. So far, so good. So again, a function is 1x goes to 1y. A relation is 1x goes to multiple y's. Now, we haven't talked about math yet on these things. Easy way to determine if a set of points belong to a function. Do those points belong to a function? Why not? Well, the moment, remember I said each x value can only have one arrow coming out of it, right? So the moment you see more than one x values that have different y values, it's not a function. Because the x values are the same, but the y values are different. You cannot have that. Is that does that belong to a function? We have three answers from two people. Who says yes? Who says no? Who's just wishing class is over and you get home? Why would you say it's not a function? Well, so those of you who said it's not a function, why would you say it's not a function? Are there any numbers that have the same x value? This one and this one. Are the y's different? No. So they're the same point. So this is a function. If two x's are equal, and the y values are the same, the points are the same. So yes, this is a function. -2, 5, 5, 7, 0, 1, 4, 2. Is that a function? Are all the y's different? Automatically, it's a function. If all x's are different, then it is automatically a function. What's that? X's are the important part. Remember the pictures I had? This is a function because all the x's only have one arrow. This is not a function because this x has two arrows, means this x has two y values. So that's what you're looking for. So if each x is different, next. So if all the x's are different, then it's automatically a function. It doesn't matter about the y values. Function notation. We're used to writing an equation this way. That's just a standard equation. When we use function notation, this is what it will look like. The equation part's the same. What we're saying here is instead of writing y, we write that. This is the function notation. It's read the function f of variable x. Or instead of, you can put with variable. The way we normally read it here is f of x. That's how to shorten it. We write f of x instead of the function f. So this is the name of the function. That is the variable inside the function. right? So why is this important? Because you can define multiple functions, actually different names. For example, I can say f of x is 3x plus 2. I can say g of x is x over 5. I can say h of x is 2x plus 1 over 3. Once I define the functions, I can now use them. How do we use them? Okay, the difference between these two is how they're used. Remember, we cannot find the y value until what? X is defined. So what I have to do here, I have to say x equals 3. You have to tell you x equals 3. So what do you do from there? Anywhere you see an x, you put a 3. And you work it out. 3 times 3 is 9. 9 plus 2 is 11. So this belongs to the point 3, 11. And then if I want to put another calculation, I'll say x equals negative 3. What happens there? Again, we put anywhere you see an x, you put a negative 3 in its place. Positive, negative is a negative. 3 times 3 is 9. Opposite signs, take the sign of the larger and subtract them. 9 minus 2 is 7. So at negative 3, it's negative 7. Remember, this is an equation. Equations define graphs of graphs. In this case, lines. So whereas each of these are points on that line. Now, using functions, all I have to do is I define x inside the parentheses. I don't have to put an equation x equals 3. I define x this way. So what this tells me now is I go to this function name, this is f. Anywhere I see an x, I put a 3. And I work it out. And then I can also do the next one. I go to the function f, that's it. Anywhere I see an x, I put a negative 3. So it's negative 9 plus 2 equals negative 7. It's an easier way of writing things. Or what if I give you this? Nope. Have we defined g? The top of the page. Once you define it, it's defined until it's done. So what is g? X over 5. What is x? 10. That's how you use functions. This is the name. Go look for that function and put this in x. So g of x is x over 5. Anywhere I see an x, I put a 10. So that's the beauty of it. Here's your function name. Are you restricted to only putting numbers inside the function in place of x? No. You can put letters, you can put pictures, you can put equations, you can do anything you want to. Once you define x by whatever's inside the parentheses will replace any x you see in the equation. So what do you do with this one? Yeah. Anywhere I see an X, I put a 0. So 0 squared is 0. Two times 0 is 0, minus 0 plus 3 is positive 3. Now, if you know this stuff is so easy, don't answer it. I want to see what everybody else knows. If you know it already, fine, great, more power to you. But I want to see what everybody else knows in the class. How about this one? I go to my function f. Anywhere I see an x, I put what in its place? Negative 7. So negative 7 squared is it positive or negative? Again, if it's easy for you, don't spit it out. I need to know from everybody else. If this is easy for you, great. I'm happy for you. But I want to know what everybody else knows. It's positive 49. Negative times negative is positive 7. So 2 times 49 is here we can do this first. 7 plus 3 is 10. 98 plus 10 is 108. So far, so good. All right, same function. Here's the function again. 2x squared minus x plus 3. C. F of 5a. So anywhere I see an x, I put a 5a. So what we have here is 5a squared, which is 5a times 5a, which makes it 5 times 5 times a times a. 5 times 5 is 25. A times a is a squared. So 25a squared. Now, another way you could have done that is you could distribute it, since they're multiplied, you can distribute that in there. So we have 5 squared, a squared, 5 squared is 25, a squared. You can do either one of those. What I'm doing is order of operations. I first do special operations first. Exponents. I get rid of that first. Any more special operations? No. Multiplication, division? Yes. 2 times 25 is 50. Negative 1 times 5. So negative times positive is negative. 1 times 5 is 5a. And we can't go any further, so we're done. D. I'm going to change this to X instead of A. If I give you this, again, I don't like that they put this in there because we haven't learned distributivity yet. So anywhere we see an X, we put an X minus 4. Special operations. Is there any exponents or special? Yes, right here. So we have to do X minus 4 squared first. What that means is X minus 4 times X minus 4. I will go over all the properties of math shortly as well, because we need to know those. So what we have to do here is we have to multiply everything in this first parenthesis to everything in the second parenthesis. So the first thing we multiply the X. X times X is X squared. Now, next one. Positive times negative is negative. X times 4 is 4X. Now the next one. Negative times positive is negative. 4 times X is 4X. Negative times negative is positive. 4 times 4 is 16. So negative 4 is negative 8X plus 16. So that's what this whole first thing here equals. 2 times X squared negative 8X plus 16 minus X minus 4 plus 3. Yeah, after we finish this section, we'll go through all the properties. Any special operations? No. So we do multiplication. Here, we take this 2 and multiply to everybody inside that parenthesis. 2 times X squared is 2X squared. Positive times negative is negative. 2 times 8 is 16. X. Positive times positive is positive. 2 times 16 is 32. Negative times positive is negative. 1 times X is X. Negative times negative is positive. 1 times 4 is 4 plus 3. Whenever you get rid of parentheses in this course, whenever you get rid of parentheses, the first thing you want to do is combine like terms. We got rid of 2 sets of parentheses. So now we combine like terms. What is a term? I'm going to use the word a lot. What's a term? What defines a term? Anything separated by a plus, minus, or equal. So how many terms do we have in this example now? 1, 2, 3, 4, 5, 6. We have 6 terms. Remember, anything separated by plus, minus, or equals is a term. Let's combine all the x squares. How many x squares do we have? Just that one. So 2x squared. So that one's taken care of. Next, we have the x's. We have this one and this one. How many of them are in this first one? Negative 16. This one's negative what? Negative 1. So negative 16 plus negative 1, they're both negatives, so I add them. So that takes care of both of those. Now all the constant numbers. Here's a positive 32, positive 4, and positive 3. So 32 plus 4 is 36. 36 plus 3 is positive 39. And there's your answer. And no, we're not going to graph the next these functions because I haven't taught you guys the functions yet and transformations. So we're not going to graph those. The vertical line test. Here we have two sets of numbers. Is the first one a function? Why? What's that? All the x's are different. It's a function because all the x's are different. How about the second one? Is the second one a function? So this one is, this one isn't. Let's look at the graphs of these. So we have a point at 2, 1. We have a point at 2, 3, 4, 5. So we have a point at 3, 5, which I can connect. And then we have a point at 4, 7, which I can also connect. So here we have 1, 2. Here's 1. So there's 1 point there. 2, 3, 4, 5. So at 3, 5, we have a point there. But we have another point at 2, 0. This is not a function. If we have all the points like this, it's easy. We can look at the first value for that. Now, if we have a graph, if we look at the graph, if we can draw a vertical line anywhere on this graph and only cross it once, it's a function. If you could draw a vertical line anywhere on the graph and only cross it once, it's a function. So this one here, it fails because at 2, I crossed it at 2 points. I crossed here and here. So it's not a function. If you can draw a vertical line anywhere on the graph, and only crosses once at each point, then that equals a function. Yeah, you have that in your notes. It's on the bottom of one of your pages. So basically it says this: if you draw a vertical line anywhere in your graph and it crosses it more than once, it's not a function. So let's look at these. Is the first one a function? Yes, because I can draw. How about the second one? No, because I can draw a vertical line here and it crosses 3 times. Third one? No. Fourth one? No. Fourth one? Or fifth one? Yes, that's a function. Sixth one? It is a function because anywhere I cross a draw, it already crosses it once. If you notice right here, there's a solid dot and there's an open dot. That means I can use this point. I cannot use that point. So if I draw a vertical line there, I only cross it right here at that point. It doesn't cross the graph down here. So that's, if you have the graph, then you look at it and see if it crosses any more than once. Then you know it's a function. If it's a function, then we know it's one to one. Remember, what does one to one mean? Yeah. One to one means for every x value, there is one and only one y value. That's what the one to one means. So far, so good. So we know the symbol of the notation of functions. We know how to imply it and what it means. Finding the domain and range of functions. We're going to hold off on the range for right now. Until I tell you what these functions look like and how their transformations affect them, we're not going to talk about the range just yet. So we're only going to look at the domains. To find the domain of a function, we need to know the list of all possible x values. Allowable for the function f of x. So basically, what this is saying, find any x values that make the function undefined. That's what we're looking for. Those are the ones we cannot use. Remember, those x's could be positive, they could be negative, and they could be zero. And we're looking at those situations. Example 8. Find both of those values. So f of 1 is equal to 1 over 1 minus 3, which is 1 over negative 2, which is negative 1/2. F of 3, 1 over 3 minus 3, which is 1 over 0, which is undefined. You cannot divide by 0. So what does it tell us? Is 1 in the domain? Yes, it is. If it's in the domain, then it'll give you an answer. 3 is not in the domain because it's going to give us undefined. So in this one, what is the domain of our function? The only x we cannot use is what? Yeah, since we have a fraction, we take the bottom equation, set it equal to 0. That's the only x value we cannot use. So we can say our domain is anything except this, or we can say it goes from negative infinity to 3, and then from 3 to positive infinity. We can say either one of those. Again, we're going to go through the whole definition of these at the end of this chapter. So you could tell me beforehand which one's not going to work here, because we can see automatically that x cannot be 3. So 1's in the domain, 0's in the domain, negative 20 is in the domain. Again, the domain, again, what is the definition of domain? All possible x values that give you a solution to the equation. All right, B. G of x is equal to the square root of x plus 5. G of 16 and G of negative 7. All right, let's look at the first one. We plug in the 16 in the first one. So we have square root of 16 plus 5. What is the square root of 16? We look at what times what equals 16. 4 times 4. 4 plus 5 equals 9. So that's G of 16. G of negative 7. So we put negative 7 inside there. We learned last time that we cannot take it because no two numbers multiplied together will give you a negative number. Actually, I should put in here no real solution. Because we will find out later on that we will have a solution, but it's not real. In chapter 3, we're going to find out imaginary numbers. So negative 7 is not in the domain of G of x. Let's go one step further. What is the domain? What is the domain of G of x? Remember, g of x is equal to the square root of x plus 5. When you're asked to find the domain of a function, do we care about 5? No, it doesn't change anything. All we look at, since the domain deals with the x values, only look where the x value is. It's inside this function. 3 questions. Can x be positive? Can you take a square root of a positive number? Yes. Because the square root of 4 is 2. Can you take a square root of a 0? Yeah, 0 times 0 is 0. Can you take a square root of a negative number? No. So we know our domain is all x's greater than equal to 0. Again, once we understand more about these graphs and these functions, it'll make it much easier to do these. So that's if I give you a function. What if I give you a graph? So in this first one, the domain deals with the x-axis. So what we're looking for is, what are all of the x's? Notice these arrows on the bottom? These arrows on the bottom of the function? There and there. What does that tell us? It keeps on going in that direction. Is it going straight down? No, it's going out to the sides. So this one's going on the x-axis. It's going out towards what number? Negative infinity. It's negative on this side. Where is it going over here? Positive infinity. So the domain of this first one is from negative infinity to positive infinity. That's what it said there. How about my range? The range is the horizontal axis. What's the highest it can go? Since this has a point there, what's the highest it can go? 4. And does it stop anywhere down going lower? No. So what my range is I can go anywhere less than equal to 4. Or I can go from negative infinity to positive 4. What that was saying. I can go from negative infinity to positive 4. Or I can say that my y value, the range, the domain is from negative infinity to positive infinity. The range, I can say y is less than or equal to positive 4. Or I can write negative infinity to positive 4. Again, we're going to talk about these symbols and what it means later on. So basically, when you look at a graph horizontally for the domain, look where it's going. Where are the ends going? And the range, look where the y values take you. So looking at this one, what's my domain? What's my range? Yeah. So the domain on my x-axis, the farthest to the left I go is -4. And on the farthest right I go is 3. But this is a solid dot, which means I can use it, which is a bracket. This is an open circle, so I cannot use that number. So it's a parenthesis. So a bracket means I can include it. An open circle means I can't use it. What's my range? What is that? Yeah, the lowest I can go is 2. The highest I can go is 5. I cannot use 2, but I can use 5. Remember, it's 2 has an open circle, 5 has a closed circle. So far, so good. That's the end of that section.